Hello everyone, today we're looking at Unit 6, Lesson 5, Primary Trig Ratios, Further Practice. So we're going to focus in on this idea of angle of elevation, angle of depression today. But before we chat about that, let's review how we solve a triangle when you're given some information. So here you've been given triangle PST. When we label this triangle, we're just going to be careful how we label it, because you have to pay attention to which angle they've said is our 90-degree angle. So it says angle S is going to be 90 degrees, angle T is 53, and side PT, we'll just put side, is a length of 10. So we know angle S is our 90-degree angle, and I'm just going to label it like this. We know angle T is 53 degrees, and we know side length PT is 10. So I'm going to go ahead and label these with letters as well. We know this is side P, this is side T, and yes, this is PT, or we could call it side S as well. So when they're asking us to solve this triangle, they're asking us to find all of our unknown sides and angles. So let's start with the easiest of the three. We can easily find that third angle. So let's find angle P. Okay. That's just the sum of our interior angles, right? We know that we already have two angles. We have a 53-degree angle and we have a 90-degree angle. So we're going to add those together and subtract them from 180 degrees. So we'll have that angle P equals 37 degrees. Okay, so I'm just gonna label that in here, 37 degrees. Now we have to find some other side lengths. So if we use 53 as our theta, let's say that that's our given angle, okay, then we can label our side lengths as they relate to that theta. So we know that this would be my opposite side, this would be my adjacent side, and this would be our hypotenuse. Okay, so if we wanted to just, we'll work to find side T first. That's one of the sides we don't have. So we'll say find side T. Okay, if I have theta, well, side T is my opposite side, and I have my hypotenuse. So if we think back to SOHCAHTOA, we have to think about which trig ratio works with our opposite and our hypotenuse. That's going to be our sine. So we'll say the sine of theta is equal to opposite over hypotenuse, and then we'll plug in what we have. So our theta is 53 degrees, our opposite side is t, and our hypotenuse is 10. So we're going to put that sine 53 over 1, and we're going to cross multiply. Okay, so t times 1 is t, and then we'll have 10 times the sine of 53 degrees. Okay, if we punch that into our calculator, we're going to get that t equals 8. Okay, now that we have side t, we could set up another trig ratio to find the last side, but we have two sides. So I'm going to go back just to remind us, how can we find that third side when we already know 2 in a right triangle? We can use Pythagorean theorem. So I'm going to write a squared plus b squared equals c squared, because that's our Pythagorean theorem. Okay, so we're trying to find p. That's the side we don't have, so we're going to treat that as our a. And then our b side would be the other leg of the triangle, which we found be 8. And c is always our hypotenuse. So we'll plug in those values like that. Okay, and then we're just going to isolate p. So 10 squared is 100, and I'm going to subtract that 8 squared over to the other side, which would be 64. So p squared would equal 36, and we would take the square root of both sides, and we would find that p is equal to 6. Okay, so if I had room, I'd probably write a therefore statement. But those were all the missing sides and angles that we just found. Okay, so continuing on with our primary trig ratios, I want to introduce some new terminology today. That's the angle of elevation and the angle of depression. So let's start with our angle of elevation. our angle of elevation, it's the angle made between a horizontal surface, so angle between a horizontal surface, and when we're talking about elevation, it's generally the ground. Sometimes it will be like a body of water. We'll look at questions like that. And the line of sight of an object up in the sky. Okay, so I'm going to show you what I mean by that. So let's say that we had the ground, because like I said, it's usually going to be a horizontal on the ground because it's looking up. So we'll label this as the ground. And let's say that there's some person on the ground or there's some point on the ground, however you'd like, and they spot an object up in the air. And just an object sometimes we see up in the air, you might see an airplane. So we'll draw a little airplane. I cannot draw. Okay, there's our airplane. So if we wanted to make this a triangle, we could just draw the altitude down from that airplane. This would make our right triangle, so we know that we are working with a right triangle again. So that angle of elevation, it's the angle made between the horizontal surface, which is our ground, so this, and that line of sight up to the object. Okay, so this is our line of sight. There's some point on the ground and we're looking up at that object. That's that line that we're looking up to. And this in here would be our angle of elevation. Okay, let's take a look at what the angle of depression is. Similar idea, but instead of looking up at something, you're up kind of higher, say on like a cliff or a bridge, anything high up in the air, and you're looking down below. So when we're talking about angle of depression, this is going to be the angle made between the ground or a line parallel, and I'm going to say a line parallel to the ground because that's really the only kind you're going to see in this course, and the line of sight to an object below. Okay, so let's look at this and draw this scenario as well. So let's say that we have some person maybe up on a cliff. Okay, and let's say there's a body of water. We're going to see lots like this. Okay, and there's some boat down below that this person spots. Okay, so from this person to the boat, right? That's the line of sight that we saw in that previous example. But how do we label our angle of depression? See, these angles are always made with a horizontal, or the horizon in this case, line. So our angle of depression, some of you might think, oh, it's got to be here in this triangle. That's not true because there's no horizontal line. What we have to do is we kind of have to draw an imaginary line that's parallel to the ground, or in this case, our water. Okay, and our angle of depression is going to be right here. So angle of elevation, angle of depression is always made with a horizontal line. Whether that horizontal line is the ground or it's like an imaginary dotted line we have to draw that's parallel to the ground. Okay, that's the way the angle of depression is made. But to keep in mind, if we kind of were to go back to some of those geometric properties we learned back in grade 9, if we think of this now as a complete triangle that we've created with the cliff and the boat like this, okay, the angle of depression here creates a Z pattern essentially with the angle of elevation. So those two will be equal to each other. Okay, so those two interior angles will end up equaling each other when we're trying to work with the triangle. So let's look at some word problems for each of these. Okay, the first one says, a hiker is 500 meters from the base of a radio tower. The angle of elevation to the top of the tower is 20 degrees. Determine the height of the tower if the hiker is 1.6 meters tall. So let's start by drawing a little picture of this. So we have a hiker. This hiker is 1.6 meters tall. It says the hiker is 500 meters from the base of a tower. So we have some tower here. Okay, and there's 500 meters between them. The angle of elevation to the top of the building is 20 meters. So the angle of elevation is going to be made from his line of sight, which is going to come, we're going to say, from the top of his head, because they're telling us how tall he is. So it doesn't come from his feet, but it comes from there. And we know the distance between him and the tower is going to be 500 meters. This angle here is going to be 20 degrees, which I just want to make note of. This is our angle of elevation. Okay, and this is our line of sight. Because we're talking about the angle of elevation to the top of that radio tower. Other information, no, I think we got it all. Okay, so they're asking us, determine the height of the tower. So, well, we know the height from here to here, right? Because it's the same height as the hiker. We know this is 1.6. So we now need to find basically the height of the rest of the tower. So let's let X represent the height of the rest of the tower. So we have to look at, if we have 20 is theta, right? This is our theta. Which sides are we working with? Well, I have my opposite side and I have my adjacent side. So thinking about SOHCAHTOA, which trig ratio we're going to use? Well, O and A come from our tangent ratio. So we'll say the tangent of theta is equal to opposite over adjacent. Theta is 20 degrees. Our opposite side is X, and our adjacent side is 500. So we will put that over 1 and cross multiply. So 1 times X is just X, and then we'll have 500 times the tangent of 20 degrees. So X will equal. And whenever you're answering these questions, we should always round right at the end. So I like to leave 3 to 4 numbers after the decimal, and then when we're doing our final answer, we'll round at that point. So let's say leave 4 decimal places until the final answer. Okay, don't round to 1 decimal place until you're completely done. So that's the value of X, but the question's asking us to determine the height of the tower. So our total height is going to equal X plus 1.6, right? That height of our hiker. So we'll have 181.9851 plus 1.6, which when we add those, we can then round, and it will round to 183.6. So we'll just say, therefore, the height of the tower is 183.6 meters. Right, so that's for angle of elevation. Let's take a look at an angle of depression question. So Todd is standing on top of a cliff, 80 meters above a lake. The angle of depression to a raft on the lake is 23 degrees. Determine the distance to the raft from the base of the cliff. So again, now we have somebody standing on a cliff. Todd is standing on a cliff. Okay, and we have water again. This time we have some raft, not a sailboat maybe. Some raft on the bottom of water. And down to him, first of all, the cliff is 80 meters tall, it says. The angle of depression to a raft on the lake is 23 degrees. So remember that angle of depression, we have to draw that imaginary horizon. So from where Todd is standing, we'll just extend that to make that horizon line. Okay, so this is our horizon, because it's always made with a horizontal line. So our angle of depression is going to be 23 degrees. And remember I said this angle makes a nice, Z pattern with this angle in our triangle. So we know this is also 23 degrees. So that gives us some more information. The question is asking us to determine the distance to the raft from the base of the cliff. Well, here's the base of my cliff, here's my raft. So we're trying to find this side here. So let's let X represent the distance from the raft to the cliff. So again, we have to look at what are we working with here, what sides did they give us so we can determine which ratio to use. So if this is my theta, I have my adjacent side, and we also have our opposite side, because remember this is my 90-degree angle here. So if I have my opposite and my adjacent, that tells me I'm going to use tangent of theta, which is equal to our opposite over our adjacent. So the tangent of 23 degrees is equal to 80 over x. We'll put that over 1, and then we'll cross multiply to solve. So we'll have x times the tangent of 23 degrees, is equal to 80 times 1, which is just 80. And then we will divide both sides by the tangent of 23 degrees. So when you calculate that, you should get 188.5. So we'll just make sure we answer that question. So therefore, the raft is 188.5 meters from the cliff. Okay, so just working with angle of elevation, angle of depression, but still using those primary trig ratios. That's all for your notes for today.